We are continuing our study of trig. We're in Chapter 4 and we're taking a look at goal number 2. And our second goal is to use right triangles to evaluate trig functions. And we want to specifically get to where we're talking about the 6 different trigonometric functions. I know that you guys are probably perfect and know everything about right triangles, but I just want to review some terms just to make sure that you haven't forgotten anything from your days in geometry. So let's take a look at Roman numeral 1. The figure below shows a right triangle with one of its acute angles labeled as theta. The side opposite the right angle is known as the hypotenuse. Good. We'll label the side opposite as the hypotenuse. The other sides of the triangle are described by their position relative to the acute angle theta. One side is going to be opposite theta and the other side is adjacent to theta. So you can see where theta is placed in this example. And so the side on the other side of the triangle, or the opposite side of the triangle, is considered the side opposite theta. And then the side that creates theta, one of the sides that creates theta, would be considered the adjacent side. I want to clarify just a little bit that when we are talking about a right triangle, the right triangle has 3 sides, just as any triangle has. But to get more specific, we always refer to the sides that create the right angle as legs. So even though I have the word side opposite the angle, I want to make sure you are referring to it as the opposite leg, and referring to the side, the adjacent side, is the adjacent leg. So again, in a right triangle, the 2 sides that create the right angle are referred to as the legs of the right triangle, and the side opposite the right angle is referred to as the hypotenuse. And I know that you know those things. Recall that the hypotenuse is always the longest side of the right triangle because it is opposite the largest angle of the right triangle. All right, so let's review SOHCAHTOA that you learned in geometry. SOHCAHTOA is spelled SOHCAHTOA. And SOHCAHTOA helps us to remember the ratio of the trig functions compared to the sides of a right triangle. So in our right triangle under Roman numeral 2, I'm going to label the bottom left acute angle as angle theta. I could have chosen to label the top right angle as theta, but I'm just choosing the bottom left. So remember, with our trig functions, sine, the SO in SOHCAHTOA, the O and the H represent specific sides of the right triangle. So for sine, the O is the opposite and the H is the hypotenuse. Remember, with opposite, it's always a leg. So the opposite leg. So the value opposite theta divided by the hypotenuse will give us the sine of a right triangle, or the sine of that angle of a right triangle. Cosine, CAH, represents the adjacent leg over H, the hypotenuse. So the adjacent leg's value divided by the length of the hypotenuse gives us the ratio of cosine. TOA, T-O-A, is the shortcut for the ratio for tangent. O represents the opposite leg. H is the adjacent leg. So the tangent is represented by the leg on the opposite side of the angle theta divided by the adjacent leg of angle theta. All right, so let's talk about the reciprocal functions of sine, cosine, and tangent. I know that you learned sine, cosine, tangent in geometry in Algebra 2, but I don't know if you ever learned the reciprocal functions. The reciprocal of sine is called cosecant, and that is abbreviated CSC. So if the sine of angle theta is the opposite leg divided by the hypotenuse, then the cosecant is the hypotenuse divided by the opposite leg. The reciprocal of cosine is referred to as secant. Secant is abbreviated SEC. The secant of angle theta is the reciprocal of the cosine, so the reciprocal of adjacent over hypotenuse is hypotenuse divided by adjacent. Finally, the reciprocal of tangent is called the cotangent, abbreviated COT. So if the tangent of theta is the opposite leg divided by the adjacent leg, then the cotangent of theta is the adjacent divided by the opposite. Now, it's not really necessary to memorize the ratios for cosecant, secant, and cotangent as long as you recall that these are reciprocals of sine, cosine, and tangent. Let's try example 1. Evaluating trig functions. Find the length of the missing sides, then find the value of each of the 6 trigonometric functions. And when I say the 6, I mean the original function, sine, cosine, tangent, and the reciprocals, cosecant, secant, and cotangent. Well, if we look at triangle ABC, I notice that we have already been given side B and side A, but we have not been given side C. Just as a quick review, recall that when you label the parts of a triangle, the capital letter represents an angle, and then the side opposite that is represented by a lowercase letter. So before I can find any trig ratio with the hypotenuse, I have to find the hypotenuse. Do you recall with right triangles, we can use the Pythagorean theorem to find missing side lengths. The Pythagorean theorem is a square plus b square equals c square. So to find the hypotenuse, we would take the value of a square plus b square. 3 squares is 9, 2 squares is 4, 9 plus 4 is 13, and so to find the value of c, we would take the square root. So the hypotenuse is the square root of 13. So let's go ahead and find our trig ratios. We know that sine is opposite over hypotenuse. The sine of angle theta is opposite over hypotenuse. Here's angle theta. The leg opposite theta is 3. Our hypotenuse is root 13. At this time, you do not need to take your time to rationalize. I'm okay with the denominator having a radical in it for now. Cosine of theta, we know, is adjacent over hypotenuse. The leg adjacent to theta is 2 over our hypotenuse, the square root of 13. And lastly, we know that tangent is the opposite leg over the adjacent leg, so 3 divided by 2. So the reciprocal function should be pretty simple. The reciprocal of 3 over root 13 is root 13 over 3. So the cosecant is root 13 over 3. Secant is the reciprocal of cosine. So the secant of angle theta is root 13 over 2. And cotangent is the reciprocal of tangent. So the reciprocal of 3/2 is 2/3. Before we leave our discussion, I want to make just a few observations. First, as you recall, the hypotenuse is always the longest side of a right triangle. So the square root of 13 is somewhere between 3 and 4. So I know that 3 and 4 is a number positioned between 3 and 4 is bigger than both 3 and 2. So a good thing to note is that when you are finding the sine and cosine, their values should always be less than 1. If their values are greater than 1, then you're saying that your hypotenuse is not the longest side. Tangent can be greater than 1 or less than 1 because you're looking at a ratio of legs. So that's okay. One other thing I want to point out is that tangent is the ratio of sine divided by cosine. All right, how did I come up with that? Well, let's look at our ratios for sine, cosine, and tangent of example 1. If tangent is equal to sine divided by cosine, I'm going to prove that to you by replacing sine theta with 3 over the square root of 13. And I'll replace the cosine with 2 over the square root of 13. If we reduce this fraction, or if we keep the numerator, switch it and flip it, we see that the root 13s cancel and tangent is 3/2. So in other words, the ratio of sine divided by cosine will always give us tangent. What's the reciprocal of sine divided by cosine? The reciprocal is cosine divided by sine. So the cotangent of theta is also equivalent to cosine divided by sine. So I want you to make note of these final two observations. In addition to thinking of tangent as opposite over adjacent, we can also think of it as sine divided by cosine.